that, we're going to get into something that's known as coterminal angles. Now, we talked about how an angle is formed from having an initial side, and then we rotate it, and we end up with the second ray, which is the terminal side. Coterminal means if you have two angles that are in standard form, that these two angles have the same terminal side. And these three angles are coterminal angles of one another. Now, these are not the only examples, this is just one. And I tried to draw them out here on these three diagrams. 45 degrees in standard form, 405 degrees, notice all the way around 360 and 45 more, and then negative 315 degrees. Instead of going counterclockwise, I go clockwise, 315 degrees, and of course that means that this is 45 degrees. What's key here, and we're going to talk about this in a lot more detail later, is that for these circles, let's say for example that these three circles were unit circles. This point here of intersection between the terminal ray and this circle, as well as this point, as well as this point, they would all have the same coordinates. So when we start defining trigonometric ratios and such, you're going to see that that comes into play, which is a little bit of a tip-off of what's coming up here soon. Now, we can write coterminal angles, whether it's in degrees or whether it's in radians, by using the following notation. This is a little different because kids aren't used to some of this, but in this case I have theta plus 360 degree k, where k is an element of the integers. So this is all the integral multiples of 360, whether they're positive integers or negative integers. And that will give you a coterminal angle with theta. In radians, we just changed the 360 degrees to 2 pi radians. It's essentially the same, theta plus 2 pi k, where k is an element. This little weird symbol means it's an element of capital Z there with the extra slash, which is the set of integers. So if I ask for you to write out all the coterminal angles to pi over 4, I'm just going to use this notation here. I'm going to write pi over 4 plus 2 pi k, comma, k is an element of the integers. I'm not going to try to list them all because there's infinitely many coterminal angles for any angle. That's, integers are an infinite set. So let's go over here now and look at a couple of examples that involve finding coterminal angles to a particular given angle. Like in this case, in part A, it's 1,230 degrees. That's some big size angle there. Find an angle that's coterminal but is between 0 and 360. So what I'm going to do here is I'm going to use the fact that I have multiples of 360, either added or subtracted depending if k is positive or negative. I'm going to subtract 360 off of this. That gives me 0.76. Still too big. That's got to be between 0 and 360. Let's take off another 360. 0.13. And if I didn't mess up, and I think I messed up in my arithmetic, shame on me. Holy moly. I should start the video all fresh with that. That was terrible. Let's try this again. 0.7. I borrowed one, so this is going to be an 8. 870 degrees. Now I'll subtract 360. That's going to be 0.15, 510 degrees. Still too big. Still too big. 510 degrees minus 360 is going to give me 0.51. At least I hope it does after all messed up. 150 degrees would be a coterminal angle between 0 and 360. Now that's coterminal, and so is 870. And of course the original here, but we're looking for one between 0 and 360. Now when the angle is a lot bigger than 360, instead of subtracting 360s, let's say it's negative, I start adding 360. So if I add 360 to this, well, that turns out to be a positive 30 degrees, and that's right there, and there's my answer. So I kind of lucked out. But this could have been negative 3,300 degrees, and so we would have been adding 360s or adding a multiple of 360. Because if it's a really, really big number, you don't want to be subtracting or adding 360s again and again. So you would look for a multiple of that you could add or subtract. Now let's try the same thing, only this time let's go in terms of radians. Find an angle coterminal to theta over the interval from 0 to 2 pi. Now notice how the difference in the stating of the question. Here it's talking about an angle between 0 and 360. Here it's saying on the interval. Again, trying to bring in the idea how the length of a line segment or circumference of a circle and how the angle measures in radians kind of pair up with that. That's why we don't write down RAD every time, we can write it as a simple number like we would do a number on the number line. So I am going to, in this case, this is too small, it's negative. I am going to add 2 pi. So common denominator would be 8. This would be 16 pi over 8. This is going to be 15 pi over 8. And that is between 0 and 2 pi. It could be equal to 0, but not equal to 2 pi. Right there it is. I know this is smaller than 2 pi because 15 divided by 8 is smaller than 2. Now this one is too big, and I know this is bigger than 2 pi because 19 divided by 4 is 4.75, so that's way too big. So I'm going to be subtracting 2 pi. Now 2 pi, remember, is 16 pi over 8. So I'm going to be, actually we want a common denominator of 4. So let's go with 2 pi being 8 pi over 4. So I'm going to subtract 8 pi over 4. That gives me 11 pi over 4. Still too big. Subtract 8 pi over 4. Actually, maybe I should put arrow instead of equals. And that would give me 3 pi over 4, and that guy is certainly within the 0 to 2 pi limitation there. Again, you can tell it's between 0 and 2 pi. First off, it's positive, so it's bigger than 0, and 3 divided by 4 is less than 2, and then you know. Now, when we were first defining the idea of radian measure, we talked about how the angle would be equal to the length of the intercepted arc divided by the radius of that circle. Well, now what I want to do is I want to multiply both sides by r and see about finding arc length. It says right here, given a circle of radius r, the arc length s of the intercepted arc by the central angle in radians is theta, is given by s equals r theta. Well, that's exactly what I would get if I multiply both sides by r. Now this comes into play because sometimes they're not interested in finding the angle, sometimes the angle is given, and they're interested in the intercepted arc. Find the length of an arc made by an angle of 220 degrees on a circle with radius 9. Well, I got a problem. My theta here, my angle measure, is not in radians. So the first thing that I'm going to do is figure out what this is. So I'm going to write d over r equals 180 over pi. The degrees and the radians, that's my proportion that I use. So I'm going to plug 220 in for d. I'm going to cross multiply. I get 180r equals 220 pi. I'm going to divide by 180. And I get r is equal to, now I can divide top and bottom by what, 20? I get 11 pi over 9. Now I can go to the formula, which is underlined right here. My arc length is going to be equal to 11 pi over 9 times my radius, which happens to be 9. So that's kind of nice. This is 11 pi. And this is an arc length, and it is in feet. Okay. Now there's a different version of this formula that you can use, especially when they give you the angle in terms of degrees, because it converts it into radians. The formula is S equals theta over 360 times 2 pi r. So it's a fraction of the circle times the circumference of the circle. So if I was to do the same problem using this formula, and I'm going to circle this, this is not in the textbook. It's a good one to remember though. I'm going to plug 220 into here. I would get S equals 220 over 360 times 2 pi r. Well, if you divide top and bottom here by 20, I get 11 over 18 times 2 pi, and I forgot to plug in my radius. My radius is 9. So 2 pi times 9, that would be 18 pi. And that's over 1. So the 18s cancel out, and I get 11 pi. And this, again, is in feet. I get the same answer either way, but you can see that little extra work here as compared to having it all set up right here in the formula. So if they give you the theta, or the angle, in terms of radians, go here, otherwise go here with degrees. Now, it kind of depends on the situation, but that would be probably a good rule of thumb to follow.